Now let's take the next set of questions. Find the distance of the point 1, 2 from the straight line having slope 5 and passing through the intersection of these two lines. Now let's sketch what the question says. There is a point 1, 2. We have to find the distance of this point from a line. And since it is saying distance, it is understood that it is asking for perpendicular distance from a line whose slope is 5. That is, the slope of this line is 5. And this line is passing through the intersection of two lines. Let there be two lines. This line is x plus 2y is equal to 5. And this one is, let's say, x minus 3y equals to 7. Our line is passing through the point of intersection of these two lines. Point of intersection of these two lines through which our line is passing, and the slope of our line is 5. Now this is quite easy. If we find the point of intersection of these two lines, we will get the point. Our line is passing through this point and its slope is 5. Therefore, we can find the equation of our line using 1 point form. This will act as x1, y1. So, first of all, we'll find out the point of intersection by solving these two equations simultaneously. Is 7 minus plus minus. This gives you 5y is equal to minus 2. So, y comes out to be minus 2 by 5. If we put this value in any of the equations, let's say we are putting in this equation. So, minus 4 by 5 is equal to 5. Y is equal to, or rather, x is equal to 4 by 5 plus 5, which gives you 29 by 5. Therefore, the point of intersection are 29 by 5 comma minus 2 by 5. This now acts as x1, y1. And slope we already know. So, we can find the equation. Plus 2 by 5, 5 times x minus 29 by 5. So, what do we get? 2y plus 2 or 5y plus 2 upon 5 is 5 times 5y minus 29 upon 5. 5 and 5 goes away. 5y plus 2 is equal to 25y minus 145. So 25y minus 5y, 145 goes on the left side, we get 147. This is the equation of our line. And now, since we know our equation, we can find the perpendicular distance using the concept. Bring every term to one side. Now this is x. This is x. This is x. So 25x minus 5y minus 147 divided by coefficient of x square, that is 625, coefficient of y, that is 25. Take mod and put value of x as 1 and put value of y as 2. So 25 into 1 is 25 minus 5 into 2 minus 147 divided by 650. So this gives you minus 10 and 15. This is minus 132 upon root 650 mod, and since distance cannot be negative, therefore the answer is 132 upon root 650. This is the distance of this point from the line whose slope is 5 and is passing through the intersection of these two lines. This distance is root 132, or rather 132 upon root 650 units. I hope you've understood the question. Let's take the other question. Show that the product of perpendiculars on this line from the points is b square. That is, suppose this is a line. This is line x cos theta upon a, x cos theta upon a, y sin theta upon b equals to 1. And there are 2 points. Let's say this point is root of a square minus b square comma 0. And let's say there is another point minus root a square minus b square comma 0. So he is asking you to find the product of the perpendiculars. You drop perpendiculars from these 2 points on this line, and let's say these perpendicular lengths are P1 and P2. So we have to show that P1 into P2 is equal to b square. Okay. So what we do is, we know how to find the perpendicular distance. So either you take the LCM or keep it as it is. There is no difference whether you take LCM and then follow the process or take it as it is. Therefore, for P1, what we'll do is take mod x cos theta upon A plus y sin theta upon B, bring all terms to one side, minus 1, divide by coefficient of x square, that is cos theta upon A whole square, plus y coefficient is sin theta upon B, its square, and add them and take square root. In place of x we will put this point, that is a square minus b square, and in place of y we will put 0. This will give us P1. Similarly, we will find P2, x cos theta upon A plus y sin theta upon B minus 1, and divide by cos theta upon A whole square plus sin theta upon B whole square. Mod. Now instead of x we will put these values, minus a square minus b square, and this would be 0. So let's solve this. We get a square minus b square cos theta upon A minus 1 upon, for convenience let's say since these and this part is same, we will put this as k so that we don't have to write it again and again. So this is upon k. This is P1. Similarly, P2 is minus of a square minus b square cos theta minus 1 upon k. This can be written as, if we take minus common, we have root of a square minus b square cos theta plus 1 upon k. Now we have to multiply P1 and P2. So therefore it becomes a square minus b square cos theta minus 1 into a square minus b square cos theta plus 1 upon k into k becomes k square. Now this is a minus b, a plus b. Therefore what do we get? A square minus b square, that is a square minus b square into cos square theta minus 1 upon k square. Now what is k square? K was this, so that the square root goes away. We have cos square theta upon a square plus sin square theta upon b square. Now this would be upon a. This would be upon a. So therefore this will take LCM, therefore it becomes a. This a will be taken as LCM, therefore it becomes minus a, and this becomes plus a, and a into a will become a square. So therefore this into a square, and this will come out to be a square. Therefore what do we get? A square minus b square cos square theta minus a square upon a square b square cos square theta plus a square sin square theta upon a square b square. A square and a square gets cancelled, and we will have a square minus b square cos square theta minus a square upon, if we convert this sin square theta into cos square theta, we will have to use sin square theta as 1 minus cos square theta. Why are we thinking of this? Because in the numerator we have just cos square theta, we don't have sin square theta, therefore we are trying to eliminate sin square theta. So b square cos square theta plus a square 1 minus cos square theta, and b square goes in the numerator. Now what do we get? This is different. So we have a square minus b square cos square theta minus a square, and in the denominator we have b square cos square theta plus a square minus a square cos square theta into b square and mod. Now if you look closely, this is a square minus b square cos square theta minus a square, and in the denominator we have a square minus b square cos square theta into b square. Now if we take negative sign out, numerator and denominator gets cancelled. We have a square minus b square cos square theta upon a square minus b square cos square theta, and we have b square. This and this goes, we are left with minus b square, and since it is mod, it will return a positive output. Therefore what do we get? We get b square, and this is what we had to prove that the product of perpendiculars from the point plus minus under root a square minus b square comma 0 to the given line is b square.